So what I've got here is a Weil-McLain 480 boiler that All Steamed Up has installed in their sort of idiosyncratic way. This is a gas-fired boiler. Although it started out, the design life of the 80 series started out as a oil-fired boiler. But here we have a commercial Carlin burner hooked up with the commercial style gas train. See if I can get a good shot back there. Where are you? Oh, there you are. So there's the 2-inch gas main that we installed. Comes in. Goes through a service valve, pressure reducer. And this is a low pressure cutout, safety switch. This is a shut off, another shut off, and this is a high pressure gas valve and isolation and servicing valve. So this is a commercial boiler in a commercial setting. There are two low water cutoffs. This is the operating low water cutoff, McDonnell Miller style, and we put that in here because it fits right next to the sight glass in this tapping. Then, of course, there is the safeguard hydro level. We got your test here, the various test buttons. And this is set at slightly lower than the operating control. Viewing port. And normally on a Weil-McLain, they have a tapping here, which comes off, and then you're supposed to put a blow down here, the float control style blow down here, and then here is also a blow down. But we use those for the pressure controls. It's the operating control here, and this is the manual reset pressure control limit there. You can see that we've set this at 5 pounds. And we've set this at the lowest possible pressure that we can get this to operate at. These things are designed not to operate more than 5. These systems, steam systems, are designed to operate no more than 2 pounds. So there's no reason to, if it gets up to 5 pounds, then you've got a problem. Weil-McLain usually has the pressure controls set in a tree which comes out of here. We find that's way too close to the water line, so the possibility of schmutz and junk could clog that line and cause it to not operate. So if we have it up here, it'll never clog. Even so, it's easy to test. You unscrew this, blow in there, and if you can blow through, then you know your pigtail is clear. Same thing here. Disconnect the 30-pound gauge and blow in here. Make sure this blows out. You're done. With these probe type low water cutoffs, the customer doesn't have to do as much maintenance. The only maintenance that they really have to do is check the water level using the sight glass blowdown valve. This is the skim tapping here. Usually have this out so if there's any schmutz that collects, we can just take the cap off and get it out. 4-inch output. This is the 4-inch line, and it's tying into a 6-inch header, which was left over from the old system. Now, originally this was only one system, the sanctuary zone. Where is it? There you are. Sanctuary zone, you had a 3-inch line here, and this was tied in with a 6-inch line. But this is, we found, and then this went to when the social zone was added later. And we found that we only needed one boiler for each zone. So we removed the old piping, and then this was sloping the wrong way, so we had to add this 6 by 1.25 inch, reducing 90, and then use this as a drip to send the water back to the return, back in here. This is the, it's all steel. This is the water feed, so we've got that with stainless steel or brass. It ties into the fitting there, and then we transition to copper here. There's the VXT, secured nicely. There's your manual feed, backflow preventer, and another valve up there. And there's the overall feed for the system with the check valve that the boiler inspector wants in the line. We got conduit coming down, service switch here. These are the clean out access plates here. Pressure relief valve. We've got a union nut on here, so this can be removed quickly without soldering tools. And rather than go into a big bushing, we used a 2x3 bushing here, and then use this as another skim tapping to improve cleaning efficiency. There's the other side of the return right there. We got a cap on the end for servicing, getting out the sludge. We got a full port boiler drain there, and this runs to a hose and out to a sump pump in another room. This is the wet return from the social hall system, the fellowship hall system in here, and then of course you've got a drain right there. And we got a flue, which is then supported by Kendorf. And we got a T, and what do we have here? Another boiler. We'll get to this one later. Probably another video. There's the barometric. These are the safety switches on the barometric. So normally the barometric, when the chimney is drawing, this is modulating the draft so that from this point back, the draft is stable. But if the chimney becomes blocked, which is not likely because it's been relined, but things happen, this will swing out. So hot gases will then be directed onto these sensors, which will then lock out and prevent the boiler from firing. Here's a shot of the flue right there. This is one of the valves that we removed on the when this system was tied together. And this is the new wet return that we added for this boiler here. Now, originally these were all indirects on the sanctuary zone. The indirects have all been deactivated, but they're still there. This was a coal-fired system. I think that's enough time on this particular boiler, and so I will end this video and we'll continue it discussing the other boiler in the room.